稍微小声一点吧，有点太大声。不是。 Hey guys, it's Eddie the Magic Monk. Welcome to another live maths lesson. There aren't many people here this week because I guess students have just finished their exams. So, since no one here has any questions, I'm just going to do my thing and see if anyone comes along. Okay, so what I'm going to do is I'm going to start with what the Year 12 should be learning pretty soon, and that is Earth geometry. Oops, my pen is not really working. Hang on.
You have some advantages.
Work out. Hello, we're back. I'm just gonna do something to make sure that my graphics calculator is working. And Annabelle, I can see your question. I'm not exactly sure what you mean, but we'll get to it very soon. Hmm, hang on. Okay, so just before we start, I'll let you know that I do have some periodic function videos already, so you should probably watch those later on, because yeah, that's pretty much everything I know about it. So, but I guess when you're asking how can you work out what value of x is for consecutive values of y using the quadrants. So I always like to start with the basics. So you have a unit circle, okay, and you have x on the horizontal, y on the vertical. Actually, I should probably make this even bigger than that, but so if I draw a circle, right, and then I draw a triangle inside this circle where the radius of the circle is one unit. So I have theta, that's starting from the positive x-axis. So I guess we have 0 degrees, 90 degrees, 180 degrees, 270 degrees. Alright, and that's the first quadrant, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then, so for example, if I have sine 30 degrees, okay, and if you work that out on your calculator, so just make sure your calculator is on degrees first. So where is it? Mode degrees. Yep, it's already on degrees. So if you put in here sine 30, right, you got 0.5. So when theta is 30 degrees, if theta was 30 degrees, I know this probably doesn't look like 30, so I'm just gonna change it a bit so it looks more like 30 degrees. So if you have sine of 30 degrees, then the y value would be 0.5, okay? And this right here is 1, because it's a unit circle, so the radius is 1. So the highest point it can go is 1. So this point has a vertical value of 0.5. So not sure what happened. Probably need to get a drink soon. Actually, before I even tell you that, I should probably tell you, at any point on this unit circle, y is equal to sine theta and x is equal to cosine theta at any point on this unit circle. So whatever theta is, if you want to know the x coordinate or the y coordinate on a point on the unit circle, you just type in either sine or cosine and it tells you. So let's do cosine of 30 and see what the coordinates are. So if we do cosine 30 cosine 30 and we got 0.866 0.866, so that would be the x value of this point. So this point will have a this point will have the coordinates of 0.866 and 0.5. So if I now, I guess you want to know what the value of x for consecutive values of y. So basically, if I want to go over to the other side, okay, and I want to make theta bigger than 90 degrees, so if I'm now over here, then what's going to happen is I need to recalculate the angle from the horizontal x-axis. Okay, so I start from this point, from the positive x-axis, and I draw an angle all over to the other side, this big angle here, and let's say that angle was 150 degrees, then this would be 30 degrees. Now, since this shape is a circle and the left hand side is symmetrical to the right hand side, that means that the coordinates of this point, they will have the same vertical value of 0.5, same y value of 0.5, but it will have an x value of negative 0.866. So it'll have a negative x value of negative 0.866. So now I have sine 150 equals 0.5, but sine of cosine, not sine. Cosine of 150 is negative 0.866. So you can do this with any value of theta, and it will be the same. So for example, you can put in sine 40, see what the answer is, and sine 180 minus 40 and see what the answer is, and it'll be the same. So the general rule is sine theta equals sine of 180 minus theta. Okay, so let's just try that. So let's bring out the calculator, see if I'm right. So if I put in here sine 60, see if that will give me the same as 180 minus 60. So which is sine of 180 minus 60 is 120. So let's try putting that in. So sine 60 is 0.866. And let's put in sine 120. And that's also 0.866. Now, so for example, let's try sine 45. is sine 45 is 0.707. Okay, and let's try another one. Let's try sine of 180 minus 45 is 180 minus 45 is 135. So sine 135 and see what the answer is. Sine 135. And the answer is also 0.707. So yeah, this rule works pretty well. Sine theta equals sine 180 minus theta. And what about what about cosine? So we have cosine theta. We have this value. So when the angle is 30, this value, and compared to when the angle is 150, this horizontal x value is the negative. So the rule that I'm going to make up for that is cosine theta, which is this value here, the x value is equal to negative of cosine of 180, which is this angle, minus theta, so minus 30 degrees. So using this rule, let's check if that rule works. So let's try cos of let's do 31, just a random number. So cosine 31. Oh, I just noticed my calculator's blocking the view again. So if I do cosine 31, that will be 0.857. And if I do negative cosine, of bracket 180 minus 31. So what's that? Negative cosine of 180 minus 31, and that's 0.857 again. So it's 0.857 again. So yeah, this is another rule that I'm going to make up for cosine. So yeah, that's basically sine and cos for the second quadrant. So does that answer the question or not, Annabelle? Whoa, what happened? Oh, you are here, that's good. So, did you want me to keep going to talk about the third and fourth quadrant, or you're happy with the way it is? Do you want me to keep talking about third and fourth quadrant? Does it just follow the CAST Yeah, it does, yeah. Oh, okay. So, CAST, well, since you brought it up, let's talk about CAST first. So, when you're looking at this pathetic unit circle, alright, this circle, if you look at the coordinates, all the y values over here on the quadrant 1 and 2, so y values are positive for quadrant 1 and 2. Now, what do we say y was before? Y is equal to sine theta for the line joining the angle from the line from the center to the point. So if y is positive in quadrants 1 and 2, so I'm just going to write out what's positive. So here y is positive, so sine theta is positive, sine theta is positive. Okay, now let's write what else is positive. So x is equal to cosine theta. Now, if you have a look at the x coordinates of all the points on the unit circle, all of the points along this side of the circle are positive. So over here cosine is positive, over here cosine is positive. And now let's look at tangent theta. Now tangent, which is not talked about very often, tangent theta equals opposite over adjacent, isn't it? So that means that tangent theta is y over x, because if you look at this triangle here, theta is here, opposite over adjacent, so opposite side over adjacent side, so that's x, that's y over x. So that's sine theta over cosine theta. So if you look at the two that are positive, if both are positive, then tan is going to be positive as well. But over here, sine, because cosine is negative, sine theta over cosine theta is going to be negative because one of them is negative. Over here, they're both negative. So here in this quadrant, in quadrant 3, I should have probably labeled 1, 2, 3, 4 first. But in quadrant 3, because both sine and cosine are negative, negative over negative is actually positive. So therefore, tangent theta is positive in this quadrant. Okay, so that's where CAST comes from. CAST. Cosine is positive here. Every ratio is positive. The sine ratio is positive. The tangent ratio is positive. CAST. So what that means is, if I wanted to know what is sine, let's give you a random angle. Let's give you 210 degrees. Sine 210 degrees. So that's going to be, if you want to draw the triangle, it's going to be from, this is a positive horizontal axis. So all the way from here, all the way to 210, because that's 180. So all the way to here, and that is going to be 30 degrees. Okay, so that is going to be exactly the same y value as this point, but reversed. So sine 210 is going to be negative of sine 30. Okay, so you should probably still draw the diagram to make sure. So yeah, the y value is going to be negative. And then let's say if I want to know cos of, because that's 270, let's do 290. So cos 290, that's going to be 20 degrees more than 270. So all the way from the starting point, 290 degrees. So because this angle right here is only 20 degrees, so that's going to be, oops, should probably do the other one. So this angle here, 360 minus 290 is 70 degrees. So it's just going to be the same. Oops. It's going to have the same y value as cosine of 70 degrees. So it's going to be cosine of 70 degrees. Same x value, right? Whatever this is, it's going to have the same x value as that, because both of these angles are 70 degrees. Okay, so that's my take on all of this. Does that help you, or do you need something else? Just type out what you need. I'm just going to get a drink. Annabelle, are you still here? Do you have any complex questions on drawing periodic functions? Complex. Hmm. I can't find anything right now. Uh, if you want, you can email me one and I can help you do it. Otherwise, let me see if there's any in my high school textbook. Have you drawn sine and cosine curves at your school yet? Okay, well, I might give you something on that. Uh, make it a bit bigger. A Ferris wheel rotates clockwise about an axis through the point A. So this is coming out of Maths with Calculus, by the way, from New Zealand, so thank you. So let's draw the graph. Let's draw the graph first so we know what they're talking about. So if we have point A over here, and we've got some sort of circle going like that, passengers board the wheel at B. Passengers board the wheel at B. By the way, I don't even know if I can do this question yet, so we'll just work it out together. And the horizontal ground is 0t. What? Sure. Could you possibly finding the equation when given a turning point and another point? Yeah. Lily, I have done that already. It's in one of my videos, but I'll do that after I've done this, I guess. The horizontal ground, I'm just going to write it. The horizontal ground is 0t. Suppose a chair starts at B. So let's make this t. Oh, okay. Well, okay, so Lily, well, if Annabelle wants me to do yours first, why not? So if I have a turning point and another point, so let's say I have an equation and I know that this is the turning point. So the turning point is at 2, 4, and another point is at 3, 1. Okay, if I know that's the turning point and that's another point, then the curve is going to look something like this. Alright, so the other point is not the y-intercept. Yeah, it's not. I just picked a random point. So since it's a parabola, the general formula for that is y equals a bracket x minus b squared plus c. Okay, so we don't know what A is, but we know that B is going to be 2 and C is going to be 4. Okay, because with the quadratic equation, the turning point occurs at negative B, C. That's the turning point. So yeah, B is going to be 2. Wait. X. It's just B. B is going to be 2. C is going to be 4. So y equals a bracket x minus 2 squared plus 4. Alright, do we get that so far? By the way, can I just ask, how did you guys find out about this live tutorial? Lily and Annabelle, if you don't mind answering that. So yeah, we got a quadratic equation and we just have A left to find out. So when x equals 3, y equals 1, right? Because that's the other point I gave you. I said x is 3, y is 1. So you just go y equals, 1 equals, oh sweet, that's cool, Annabelle. Thank you. How did you find out about this channel? 1 equals a bracket 3 minus 2 squared plus 4. So then I just saw it on your channel when I searched for tutoring. Sweet. So Lily, are you in grade 10 or grade 11? So now I have 1 equals 3 minus 2 is 1. 1 squared is 1. So it's 1a plus 4. So a equals 4 minus 1, which is 3. So that's the equation. The equation is y equals 3 bracket x minus 2 squared plus 4. Now let's check whether I've got it right. So I'm just going to bring up another program and draw it. So in case you guys haven't downloaded it yet, you should probably get GeoGebra, because it's a pretty good program. So if I draw the equation, which was y equals 3 bracket x minus 2 squared plus 4. Well, that sucks. 3 bracket, what did it just do? Oh, I forgot a negative. So here a has to be negative because we are going down. So it has to be a negative. Wait. Yeah. So I totally rearranged this wrong, because a equals 1 minus 4, which is negative 3. So, yep, should have drawn a negative. So let's delete that. Y equals negative 3 bracket x minus 2 squared plus 4. So you can see that is pretty much the equation. I have x is 2, y is 4. That's this point here. Alright, that's this point here. And then I also have 3 and 1, which is this point here. X is 3, y is 1. So yeah, those are the 2 points. Does that answer your question? Oi Chan say boonsipi. Piece of boon. Miles, what are you talking about? Oi, what the? Okay, you're doing well, Lily. Thanks for coming. And Lily, just watch through all my algebra videos, watch through the Year 11 Maths B videos, and you'll be ahead of everyone else in your grade. Okay, so Annabelle, let's continue with the Ferris wheel. Hey, Gareth, I might need your help on this because I don't know what the question's on about. The ground is 0t. Suppose the chair starts at B. Do you do 12 Maths B? Well, sort of. Yeah, I haven't taught it for a while, but what do you need help with, Matt? Actually, I might start doing some probability next week, which is taught in 12 Maths B, if you're interested in that. Suppose the chair starts at B and t seconds later it is at P. Integration. Well, if you email it to me, Matt, I can probably work it out. Just email it to me. Starts at B and t seconds later it is at P, which has a vertical height t seconds later it is at P, which has a vertical height how long does it go for? I don't know, Lily. It just keeps going until I fall asleep. Has a vertical height of has a vertical height h above the ground. Suppose the chair starts at B and t seconds later, so the chair starts here, t seconds later, so let's say t is the horizontal x-axis. So let's say t is 3 seconds, it might be here. What? So confused. This is probably a really bad question. Anyway, just getting it out of the textbook, so don't blame me for it. Vertical height h above the ground. And h equals negative 10 cosine pi t over, I can't even read this. It looks like 15, but it could also be 1.5. God, I think I'm going blind. Just wait. No. Just gonna say 15. Plus 11. Okay, so what is the radius of the Ferris wheel? So, Annabelle, during your exam, will you have access to a graphics calculator? Yeah, we have the Casio. Oh, oh, that's sort of annoying. When you finish, plot a graph of parabola y x equals y squared. X equals y squared. So, Annabelle, do you want me to do Lily's one first again, or? But yeah, I suggest you guys download this program because it helps quite a bit. So, Lily, if you want to draw a graph, you can just type the equation in here. X equals y squared. Will that work? And okay, well, everyone wants me to do someone else's, so here is the oh, you have GeoGebra. Okay, well, y squared equals x. So Lily, that's your graph. X equals y squared, and from negative 3 y to 3. So I guess you just want it from here to about here. Alright, you just want it from about here to about here. So I guess some features you can say between there and there, between here and here, x horizontally it's going from 0 to 9. Okay, so oh, okay, that's very good, Annabelle. Your school sounds pretty advanced. Is your school in Brisbane? Oh. Okay, so that is the features, Lily. Is it free? Yes. Yes, everything's free. I mean, sorry, I don't know what I'm talking about. Everything that I'm using is actually, that's not right. Okay, forget it. GeoGebra is free, yeah. So yeah, that's pretty much it. If you had to draw the graph by hand, you could also do something like this. You can go, what was it? X equals y squared. And then you just go, whatever x is, whatever y is. You can draw these, plot this table out. So when y is 1, x is 1. When y is 2, x is 4. When y is 3, x is 9. And then just when y is negative 1, x is 1. When y is negative 2, x is 4. And then you can draw the graph by hand anyway if you wanted to. So when x is 1, y is 1. When x is 2, y is 4. You'll end up with, when x is 3, y is 9. Wait. When x is 4, y is 2. When x is 4, y is 2. When x is 1, y is 1. When x is 0, y is 0. So yeah, you end up with that. But yeah, you also need to do the negative. So when x is 1, y is negative 1. So you also need to do these ones. When x is 4, y is negative 2. So you also need to do these ones, so you end up with that parabola, sideways one. Okay, so that's how you do that graph. Gareth, are you still there? What is the radius of this Ferris wheel? So when you get an equation, the first thing I do is graph it, because you have that Casio calculator. So why wouldn't you graph it, right? So you'd graph it, so you're going to type that equation in. Y equals negative 10 cosine pi theta pi x over 15 plus 11. So that's what it gave me. Pi x over 15 plus 11. Okay, so let me delete that. So if it's giving me that, then obviously the height of your Ferris wheel is the y-axis, right? So you're going from down here when you are initially, what is it? Initially you're 1 meter off the ground. And then you're going to go your highest point, and the highest point is, oh, I'm looking at the x coordinate, the y coordinate. So highest point is 21. So yeah, you're just going from 1 to 21, back to 1, back to 21, and so on. So yeah, that's basically what your Ferris wheel is doing. Your height keeps going up and down. So if your height keeps going up and down, right, and it's a circle, that means that the radius must be halfway between the highest point and the lowest point. Must be halfway. So that means the radius is half the amplitude. Okay, and amplitude is 10, right? Oh wait, the amplitude is 10. Equals 10. So that's the radius. It's the radius of your Ferris wheel. Let me just check the answer for that. What is the radius? Exercise 4.212a. So it's 4.212a. Radius is 10. Hooray, we got it. Annabelle, does this question interest you? Should I keep going with this, or you run off doing something else? Tonight is very quiet. Oh, okay then. Well, let's keep going with this. The next question, what is the height of B above the ground? Okay. See you later. It's funny, I actually want to keep going with this now. Height of B above the ground. So B, I guess, is the lowest point of the Ferris wheel, isn't it? So B is right here. So the height of B above the ground is going to be the lowest point, which is 1 unit above the ground. So let's, you lied. Oh, okay. Now the reason why I want to keep going is because I'm actually interested in this now. So let's check that. Question 12b. Exercise 4.2, question 12b. Exercise 4.2, question 12b. Yes, I'm right again. Height of B is 1. Okay, question C. How long does a complete revolution of the wheel take, assuming it does not stop? So let me just type that out. Oh, that's a nice emoticon. So I have the equation. Wait, what am I typing out? How long does a complete revolution of the wheel take, assuming it does not stop? So looking at the graph again, if I'm starting at this lowest point and I go all the way up and down again, how many seconds does it take? 30. Okay, it takes 30 seconds, but it's pretty easy to see with the graph, but you probably need some sort of way to do it. And yeah, that's probably the same with this, like what is the height of B? So you probably should use some equation. So let's see if I can help you with that. Translate the curve y equals cos x . Two pi over b. Okay, so the period is equal to 2 pi over b. From the equation we know that b is pi over 15. Yes, you're right. So b is equal to pi over 15 from this equation. So 2 pi over b is 2 pi over 15. So put that in your calculator. Or you can just do 2 pi times 15 over pi. So that gives you 30. So that's the complete revolution of the wheel. Yes, Annabelle, you're right. What about the height of B? How would you do that algebraically? No idea, okay. So, the height is the minimum point. Equilibrium is 11. Yeah, that's it. Yeah. Yeah, it's very good. That's how you do it, Annabelle. So, what is the height of B above the ground? So, the equilibrium, which is halfway between the top and the bottom, is originally on the x-axis. So, if we move that up to y equals 11, and the amplitude is 10, that means that the minimum value must be y minus the must be the equilibrium minus the amplitude. So minimum h equals 11 minus 10, which is 1. But Another way you can think about it, is the equation is h equals negative 10 cosine whatever it is. Wish it were 8 hours ago. Trent, what time is it in Toronto? Gangsta. 6:25 a.m. So you should have just woken up. Tell me you just woke up. Oh no, why were you up all night? So h equals negative 10. Now you can say cosine ranges from negative 1 to positive 1. Right? This value in the middle cannot go beyond negative 1 to positive 1. So if we want the minimum h, the minimum occurs at negative 10 times. Now if that was negative 1, that'll give you 10 plus 11, so that won't be the minimum. So the minimum will have to be times 1 plus 11. So that'll be negative 10 plus 11, which is 1 again. So you can say minimum h occurs when cos theta equals 1. Right, that gives you the minimum h value. So yeah, that's my take on it. Is there another question? How high above the ground is the highest position? Well, we don't need to go through that, do we? Rehearsing. I'm a professional musician. Oh, Trent, that's great. If you want, you can put your YouTube channel here and we'll go check it out. Oh, okay. So you don't want the highest position? Okay. Because that's just the equilibrium plus the amplitude, but yeah. Find the height above the ground of a chair 10 seconds after it started at B. So basically it's just saying substituting t is 10 into the equation. So find height of chair at t equals 10. So do we need to go through that, Annabelle? What else? A chair starts at B and t seconds later it is 13 meters above the ground. Find the two values for t. The worship. Alright, well, Trent, I'll look you up. Trent, do you want us to play your song here or... Oh, heavy metal. Pretty cool. Nice song. The worship. I'll subscribe to you. Oh, you got quite a few subscribers. Well done. Awesome. Okay, so Annabelle, unless I hear more from you, I guess we'll stop there. A chair starts at B and t seconds later it is 13 meters above the ground. Find the two values of t. What is the equation of the circle which represents the Ferris wheel using the given axis? I guess that is probably the hard one. Because, the equation of the circle. Yeah, that's the hard one. Because I guess it means we want the equation of this circle. Which is sort of confusing because we need a few points, don't we? So we need it so that when x is 0, y is y is 1 and what is it? 1 and 21. So we want 1 and we want 21. And then this point is 11. That's the center of the circle. That's probably enough anyway, isn't it? So let's go to GeoGebra, my favorite program. Favorite program. Let's delete all that. So I know that the equation of the circle is x squared plus y squared equals 1. Now, if I drag this up, well, let me drag it up. You can see that you're just moving the center point. So if I want the radius to be, what is the radius? The radius is 10. So I'll just do radius as 10. And then I need the center to be at what? Radius is not 10. The radius is, wait. Let's just try 100. Now the radius is 10. So let's put here x squared plus y minus 11 squared equals 100. So yeah, I guess that gives me because we got x equals 0, y is 21, x equals 0, y is 1. And then the midpoint is x is 0, y is 10. So let's see if that is good enough. Exercise 4.2, question 12. Yes, it is the right answer. It is the right answer. Can't believe it. Okay, where did I get the 11 from? So basically, you have the circle. Alright, you have the circle. Now, the 11 comes from originally I had x squared plus y squared equals 1. That's a small circle down here. Right, but that's not going to help because firstly we want our circle to have a bigger radius. So I change this to 100. That controls the radius of the circle. Okay, if I make it 100, then the radius is going to be 10, isn't it? So the radius is the square root of the number in the end. And now we're going to move it up. So to move it up, you plus the y value. So you plus the y value here. And we want to move it up by 11 units. Oh, sorry. We minus the y value to move it up 11 units. So now we're here. And then that's the answer. It's just the vertical translation. Okay, well, Annabelle, I'm guessing you want to go and study biology or something, like you said before. Am I right? Okay then, well, it's been good having you, Annabelle. Thanks for coming today. Oh, that's great. I'm glad it helped. Okay, see you next time. So, I guess I will now go to 12 Maths A, like I planned to do. Might save this template. What is it? It's called Ferris wheel question. Hey guys, it's Eddie the Magic Monk. Today we're doing another live stream, and since there aren't many people here, I'm just going to teach you a bit of latitude and longitude, which is taught in year 12 maths A. Year 12 maths A. And the topic is Earth geometry. So yeah, what is involved? Well, firstly, let's talk about the concept of latitude and longitude. Two things you have to understand. Basically, everything in this topic revolves around that. So if I have a circle, which is pretty hard to draw in this program, so I'm just going to switch to another program to borrow a circle. Will it paste in here? Yep. So if I have a circle and it's taking a while to draw a circle, sorry about that. And I divide the circle up into horizontally. Okay, divide the circle up horizontally. Then what's going to happen is, if the circle was in 3D, okay, if the circle was in 3D and each of these lines went all the way around the sphere, okay, so this was a sphere, then the longest circumference is going to be in the middle here. This middle line is going to have the longest circumference around the sphere. So this is what we call great circle. And all of these other lines that are parallel to the great circle, they're going to have a smaller circumference. So these are called small circles. So that's small, small, small. And the greatest one will be right in the middle of the sphere. This line will be crossing the center of the sphere. It's called the great circle. So if I draw another circle again, and this now represents the Earth. Okay, we have a line through the center of the circle called the equator. Patrick Dalton. How's it going? The equator is in the center of the circle, and we call this 0 degrees How do you know the equator is straight? We call this 0 degrees. Latitude. And then these lines will go up in multiples of 10 until we get to 90 degrees. So let me just actually I'm just going to go 0, 30, 30 degrees north, 60 degrees north, and then 90 degrees will be right at the top. So where are these degrees coming from? Okay, where are these degrees coming from? So they come from, if you start from the center of the earth and you draw a line going from the center to the circumference, right? This angle here, 30 degrees, is what determines the number for the latitude. So again, this angle here would be 60 degrees, and that's why we have the latitude line of 60, and the top is going to be 90 degrees. Okay, so it just keeps going up. So that's basically latitude is horizontal lines. Horizontal lines. Let's talk about longitude. So if I draw another circle, represents the Earth again, but this time, instead of dividing up the Earth at the middle, instead of dividing up the Earth here at north or south, I'm going to go to where it was 90 degrees before, and let's say this is the North Pole and this is the South Pole, and I'm going to divide up the circle vertically. Okay, so this line goes through the center of the circle. This is a great circle again because it's impossible to have another circumference around the circle that is longer than this circumference, because this is already at the longest part. Right? If I drew a line down here, that wouldn't be a great circle. That would be a small circle. So if I drew some other longitude lines, right? If I drew a few more lines all going through the North Pole and South Pole, they would all be great circles. It's a bit hard to draw these lines, but all of these would be great circles. So these are called lines of longitude. Lines of longitude, and again, we'll put some measurements on. So we'll have again 0 degrees is the line in the middle, and this line here at 0 degrees is called the Greenwich meridian. This line through the middle here, which I'll label right now, it's called the Greenwich or Greenwich, but yeah, I'm pretty sure it's pronounced Greenwich meridian. Greenwich meridian, 0 degrees. Okay, and it can go east or west again, so where is it going? To the east, so let's say we can go all the way to 180 east. So let's put in multiples of 30, 60, 90. So it can go all the way around to 180. So let's put east, east, east. And then we got 30 degrees west, 60 degrees west, 90 degrees west. It can go to the west, it can go to the east. Just gonna get another drink, I'll be right back. So we have the Greenwich meridian is at 0 degrees east, 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 west, west, west. So these are the lines of longitude. Now, every point on Earth can be identified using its latitude and longitude. Okay, so let me give you an example. Okay, let me just find some information on latitude and longitude of different cities. So let's say Shanghai. Actually, I'm just going to show you this on Google Earth. So Shanghai is located, so as you can see here, I've labeled the Earth I've turned on grid lines, so got view grid on my Google Earth. So in case you're using Google Earth, you probably want to turn on grid lines. And you have the equator, which is in the middle, 0 degrees. And then if you zoom in to a city, let's say I want to go to Shanghai, which is here. It will be located at, let's say it's 30, actually you can just move your mouse on it and it tells you 31 degrees, 12 minutes and 11.25 seconds north, 121 degrees east. Okay, so you can see that Google Earth uses degrees, minutes and seconds, which is pretty new. So you can see here that because it's using degrees, minutes and seconds, it doesn't go up beyond 60. So 100 degrees, 27 minutes, 121 degrees, 28, 29, 30, and then when it goes up to 60, it'll jump to 122. Yes. So yeah, Google Earth uses degrees, minutes, seconds. So very interesting. So yeah, we got Shanghai, which is located at about 31 degrees north and 121 degrees east. So if I drew that on my map, I would be going from the horizontal. So let's just paste that circle again. Well, let's still paste. I've pasted it a few times now. Oh, pasted. So if I start from 0 again, and then if I go to 30 degrees north, so 10, 20, 30, so let's say about here, 30 degrees north, and then I need 120 degrees east. So that's sort of hard to draw, but let's say that this great circle is 0 degrees. Okay, let's say London is somewhere here. So 0 degrees, and then we want 120 degrees. So we got 30. Let's just call that 30 degrees east. And then we have 60, 90, and then let's say this was 120. Then that means Shanghai will be here. Shanghai will be here because that's 120 degrees east and 30 degrees north. Now you can also draw it on a normal map. So if you have a world map, you can also, if you have a rectangular world map, you can also do that. So we got 0 degrees north, 30 degrees north, and then let's say London is somewhere around here, 0 degrees, and then we have, so these are lines of longitude I'm drawing vertical, so 30, 60, 90, 120. Alright, then the intersection between 30 degrees north and 120 degrees east will be Shanghai. This will be Shanghai. So yeah, depending on whether you want to, you want the latitude and longitude on a sphere or you want it on a map, you can specify the latitude and longitude. So let's do an activity. I will give you a city and I want you to find its latitude and longitude. So let me just Google it. Latitude, longitude of cities. There's actually a list. So I want you to find the latitude and longitude James Dunligan, how do you get x in 3 to the power of x? 3 to the power of x is bigger than 4. 3 to the power of x is bigger than 4. Well, let's just graph that first. So let's delete all that. 3 to the power of x is bigger than 4. Where's my graph? It's not even here. But y equals 3 to the power of x. Oh, that's weird. So 3 to the power of x. So that's the equation. And if we want it bigger than 4,